representing injured persons in Portsmouth, Suffolk, Isle of Wight, and throughout Virginia for over 25 years. If you've been injured by someone else's...
So this is a lecture regarding Math 1127, Session 7.3. And again, it's with emphasis to homework. So for 7.3, I only included 4 questions because it's extremely similar to what you will see from the previous session. Now for example, 7.3.12t. For this problem, just like before, right, you're given the claim, the sample statistics. The only differences, so it's the same as 7.2 with only one minor difference, and that is we do not know the population, standard deviation, and the sample size is less than 30. That means we have to use the T hypothesis test. Now, so the only difference, so first let's construct the test, right? So first we gotta do the claim is the mean is particular 35. So we can just say, let me get the mean here.
Then I realized there are
choices
that have not that had choices. The doctors from the heart help me understand my options. I choose open adoption, so I can choose my baby and stay in touch with them because it was my heart, my mind, my choice. I chose adoptions from the heart.
So meal is bigger than 75. That's for the HO. Oh, I'm sorry, my bad. The less than or equal to. What's the less than or equal to? Right here. There you go. So because the claim is the mean bigger than 75, the opposite to it is less than or equal to, and that's the null hypothesis. So now let's go to the other one.
You have plenty of time. Go to your local community college, get one of those programs, if you will, or curriculums that take you right from community college to the workplace. Community colleges specialize in areas where the jobs are and where they're going to be. And
this time it's going to be bigger than 75. And remember, that is the claim.
You have a skill, you can go to the next job. So, because those children are going to live in poverty all their life. And when you live in poverty, you're living in an area where the education system is no good.
We have these sample statistics, meaning somebody did the work for us, did the sample, look at the data, and they gave us these, which is
they will live in areas with a bad education system and with a lot of crime and pressure around them. And so they won't get a good education to be able to compete and get in good schools. They may fall victim to the crime that's all around them or the drugs that's all around them. So think that way, all right? Don't think just about yourself. Think about how you're going to make sure that they are productive
X bar
the same thing. You don't want them
is 77.4.
You end up being poor for the most part.
The standard deviation is 3.3 and equals 23. So again, it's a lot easier just to write it down, but I want to type it up. So now, all you have to do is think about this, right? This is a one sample T test. So I'll go to the calculator and go to stat test, and you want T test. So this one is not data, it's going to be a stat, right? Statistic on the right, like this. And you want to go ahead and put in, the mean is 75. And this sample mean here, right? The sample mean is 77.4. And the standard deviation is 3.3. That's a sample standard deviation. The sample size is 23. And in this case, we are talking about greater. And so let's calculate. So we have a P value is equal to 0.001. So you can then say, and remember alpha, maybe I should say up here, the level of significance is A equals 0.10. So you can just say since P is less than alpha, then you can then we reject the null hypothesis. Therefore, the evidence support the claim. So now let's look at the question over here.
Come back here.
So the first part is less than or equal to, so that should be B is the answer. There you go. And there was a standardized test statistic. So we did a P value, but they also give us the statistic, which is right here. The T, so the T stat, the T statistic equals, or test statistics equals to 3.488. And other one around two decimal places, so 3.49. 3.49. Just like that. And then the next one is the p-value, and they want you around to 3 decimal places, which is what I already have. And then we reject the null hypothesis. That should be this one. We reject the null hypothesis, and there is enough evidence to support the claim. Let's just say, maybe I should say this. There is enough evidence to support the claim. So, like that. So like that, right? Always do all the work first ahead of time, then this will work. This is the same thing, so I'm not gonna repeat this one. I want to keep going to a different problem. So this one is very similar. Let me look at the full problem and see. This one's very similar, right? It's the not equal to 25. So you just gotta make sure when you do the test, you would do this guy right here. So you do this right here instead. And also p-value you have to multiply by 2 just to see if it's bigger or smaller than alpha. So that's really, so you gotta refer back to last session if you need to, but it's the same thing. But I'm more interested in doing this one. So let's see. Now, so this is example 7.3.17 T. So for this problem, right, we have, let me copy that. Actually, I can't. So let me just do this. So for this example, we have a credit card company claims that the mean credit card debt is greater than 5,200. So the contest here is either bigger than 5,200 or less than or equal to. So let me go ahead and set up the null hypothesis. So equation. The null hypothesis is the mean. In this case, it would be less than or equal to. More so than doing and having 5,200. And the I'm just copy that. And so I hope I apologize if you say, this is bigger. And this is the alternative hypothesis. And again, this is the claim. So now, we have the, let me see, do they give us a sample statistic? Let me see, you want to test a claim? Yep, you found A, so let me copy this right here. Okay, and so that caused you to be short. And do you agree all? So basically this time, we are given the sample mean is, let me see, the sample mean is 5321. The standard deviation is 550. And the sample size is 26. And also, don't forget, right, the level of significance, which is alpha, right, equals 0.10. So now let's say the first thing we should do is go to the t-test. We're going to use t. We'll use t-test for the same reason as before. Right. Use t-test, and we go to the t-test here. And let's say we're doing stat, not the data. Right. So if they give you a list of data, you just gotta go to the data. And now, for t-test, we are looking at the mean is population means 5,200, just what you're testing for. And then the so the sample mean is 5321. Sample standard deviation is 550. Sample size is 26. And we are doing greater, right? The right tail test. Calculate. Easy, right? So the test statistics is 1.12. What is the p-value? Is 0.136. So since our p-value is bigger than alpha, than A, right? We will, if it's bigger, then we will we fail to reject. We fail to reject the null hypothesis. There is not enough evidence to support the claim. So let's answer the questions. What we got here? So let me scroll up a little bit. Less than or equal to, which is right here, and bigger. And then, what are the critical? They want critical value, the T0. This is when you have to use the formula sheet. The critical value is something you have to refer back to the first 7.1 lecture. But basically for that, let me see if I can go back to that. Back to math 1127. It's a formula sheet that I sent you guys. Right here. Let me see if I can. Let me see if I can rotate it. Right, rotate it clockwise. All right. So if you look at this right here, I know it's a little bit hard to see. Let me just make it bigger. Like this. So what it says here is
Come out there.
we have the situation we have is this. We have a t-test and the sample size is 26 and we want 0.1 level significance, right? So let's say it's a one tail test, so it's one tail and a 0.1, which is this column right here, and we're doing t-test. T-test is we are 26, it's a sample size, so that means the degree of freedom is 25. It's always one less, right? In this case, in a one-dimensional case. So you go down to 25, which is right here, right? And there's a second column, so that's 1.316. So this is what we call critical value. So the critical value is 1.316. So let's answer that. 1.316. And then what does it say? Determine the rejection region. So there will be everybody, the T, but rejection region means outside the boundary, meaning the critical value is 1.316. It's everybody who's bigger than that because you're doing Rice tail test. And again, you gotta refer back to 7.1 to know what I'm talking about. But basically, any value that's bigger than 1.316 is gonna reject the null hypothesis. So there'll be 1.316 here. So now find the standardized test statistic, which is what is it? 1.12. So now let's see the test statistic, just like this guy right here. You can also say, in other words, test statistics is less than the critical value. Because it's less than, it means you're in the safe zone. You fail to reject the hypothesis, the new hypothesis, because the test statistic is not in the rejection zone. Interprets at 10% level significance, that is not enough or not sufficient evidence to support the claim that the mean. So what is the claim? It's greater. So that's this one, greater than 52. Right? Just like that. So I mean, it's the same thing as the last session. It's just using T instead of Z. And how do we know? Sample size is less than 30, and also we do not know the population standard deviation. And that's it. All right, and I'll see you in the next video.